All right, so today we're going deep with Thomas Young. More than just the double-slit experiment guy.
Oh, way more. Yorgo Schneppat's essay frames him as like a scientific superhero. Physics, engineering, Egyptology. It's kind of crazy.
Seriously, how is that even possible?
Well, think about it. He was right there during this massive scientific shift, like bridging that gap between Newton's clockwork universe and all the quantum craziness we're figuring out now.
So he's born when everyone thinks the universe is this big, predictable machine. And his work helps kick off the era where it's like everything is uncertain and particles are in multiple places at once.
Exactly. It's almost like he was meant to be a scientific revolutionary, which Schneppat really drives home in the essay.
Okay, but let's talk about the double-slit experiment, because that's what most people connect with Thomas Young. He shined light through two little slits and saw this weird interference pattern.
Right, but the huge thing is that pattern only makes sense if light's acting like a wave, not just a stream of particles like Newton thought.
Okay, so like...
Imagine dropping two pebbles in a pond. The ripples interfere with each other, making a pattern. That's basically what Young saw with light.
So he didn't just make a cool discovery about light. He actually challenged a fundamental assumption about how the universe works. No wonder people were skeptical.
Oh, absolutely. Schneppat even mentions some scientists straight up attacked Young's work, defending Newton's particle theory hardcore. It took some serious guts for Young to stick to his guns.
Yeah, going up against the whole scientific establishment. But here's what blows my mind. This wasn't just some physics trivia. This double-slit thing basically foreshadowed quantum mechanics.
Right. All that stuff about how things behave at the subatomic level, totally different from the physics of our everyday world. Young's experiment hinted at this strangeness, even though he couldn't have grasped the full extent of it back then.
So things like quantum computers and super secure communication, they all stem from this idea that light can act like a wave.
In a way, yes. His experiment planted the seed, showing that light and later even matter can be both wave and particle, a radical idea that completely revolutionized physics.
Okay, my brain is starting to hurt. In a good way, though. So we've got the scientific rebel upending how we understand light, but Schneppat also says Young was a master of like a million disciplines. Didn't he have something to do with the Rosetta Stone?
He did. Remember how we talked about him being fluent in tons of languages? Well, he played a crucial role in deciphering the Rosetta Stone, the key to understanding ancient Egyptian hieroglyphics. Imagine unlocking the secrets of a whole civilization.
So he's like a real-life Indiana Jones. Except instead of a whip and fedora, he's got equations and scientific instruments. This guy was seriously impressive. Tell me there's more.
Oh, there's definitely more. Young also developed Young's modulus, still a fundamental principle in engineering and material science today. It basically describes how stiff a material is. Super important for building things that don't, fall apart.
Bridges, airplanes, skyscrapers, all thanks in part to Thomas Young.
Exactly. And remember, we're talking about the same guy who basically kickstarted quantum mechanics. It's hard to grasp the sheer breadth of his impact.
Okay, I'm officially convinced Thomas Young was some kind of scientific superhero. Revolutionized physics, cracked ancient codes, helped us build better structures. What else is there?
Well, Schneppat goes deeper into the implications of Young's work, especially this shift from a deterministic view of the universe to a probabilistic one. That's where things get really interesting.
All right, let's take a deep breath and try to unpack that. What does it even mean for the universe to be probabilistic? Are we saying everything is just chance?
It's not quite that simple. But Young's work, particularly the double-slit experiment, really challenged the idea that everything is predetermined. This is where superposition and entanglement come in. But maybe we should save those for part 2.
Yeah, you're right. I need a minute to process all this before we dive into the truly mind-bending stuff. But one thing's for sure, Thomas Young was a true visionary. I'm already feeling smarter just talking about him. Stay tuned, folks, because we're just getting started.
So ready to tackle those mind-bending concepts, superposition and entanglement.
Hit me with it. Honestly, I'm a little nervous. It's like we're stepping into a science fiction novel or something.
But it does feel like that sometimes.
Wow.
But it's all rooted in real science. Going back to Young's observations about light. Think about that double-slit experiment. The fact that light could act like a wave, it opened up this whole new way of thinking about the universe, especially at that subatomic level.
Okay, I'm with you so far. But how do we go from waves of light to like? Things existing in multiple states at once.
That's where superposition comes in. One of the weirdest, most counterintuitive ideas in quantum mechanics. Basically, it says a particle, like an electron, can exist in multiple states at the same time, until it's measured.
Hold on, are you saying an electron can be in two places at once? That's impossible, right?
It seems impossible, based on our everyday experiences at least. But in the quantum world, it's totally normal. Imagine flipping a coin. While it's spinning in the air, it's both heads and tails, right? It's only when it lands that it settles into one definite state. Superposition is kind of like that, but for particles.
Okay, that analogy helps. A little. So the electron is like a spinning coin, existing in all these possible states.
Until we try to measure it.
Exactly. And measuring it forces it to collapse into one specific state. It's like our observation makes reality solidify.
Whoa. So reality is kind of fuzzy and uncertain until we look at it. This is where my brain starts to melt.
It's definitely mind-bending. And it gets even weirder with entanglement.
Entanglement. That sounds ominous. What's that all about?
Imagine you have two of those spinning coins, representing entangled particles. They're linked, even if you separate them by a huge distance. What happens to one instantly affects the other. It's like they're connected by an invisible thread.
Wait, are we talking faster than light communication here? Because I thought that was impossible. Not communication in the traditional sense. More like a spooky connection. Their fates are intertwined. If you measure one particle, and it's heads, you instantly know the other is tails, even if it's on the other side of the universe.
Okay, now I'm officially in science fiction territory. So if we could harness entanglement, we could have like instant communication across vast distances.
That's one potential application, still very theoretical, but the implications go beyond communication. It's also a key concept in quantum computing.
Right. Quantum computers, those super powerful machines, solving problems in seconds that would take normal computers millions of years.
Exactly. They exploit these strange quantum phenomena, like superposition and entanglement, to do calculations in a completely different way. It's revolutionary. Potential to transform medicine materials, science, AI.
It's incredible to think this all stems from Thomas Young shining light through two tiny slits. Like he opened a portal into this hidden world of quantum weirdness.
And that brings us back to Schneppet's essay. He emphasizes the philosophical implications of all this. This shift from a deterministic universe to a probabilistic one. It's huge.
Okay, break that down for me. What does it mean to go from determinism to probability?
Determinism is the idea that everything is predetermined, like a giant clockwork mechanism. You know the initial conditions, you can predict the future perfectly. But quantum mechanics throws a wrench into that.
Because particles can be in multiple states at once, and their fates are all intertwined in these strange ways. So the universe is more like a game of chance than a predictable machine.
Exactly. The universe isn't this perfectly predictable system anymore. It's more like a web of probabilities. Chance and randomness play a fundamental role. And Young's work was key to this paradigm shift.
It's almost like he's saying the universe is more about possibilities than certainties. A little unsettling, but also kind of exciting.
Absolutely. It opens up a whole new way of thinking about reality, the role of the observer, the limits of human knowledge.
Okay, my head is officially spinning. But I'm loving this. So we've covered the double-slit experiment, quantum weirdness, the Rosetta Stone engineering principles, all in one guy's lifetime. Is there anything else we should add to Thomas Young's resume?
Well, Schneppet doesn't go into a ton of detail on this, but Young also did a lot for our understanding of how we see. Remember, he was a physician. His work on the human eye and color perception led to the trichromatic theory of vision, still a fundamental concept in ophthalmology today.
Wait, so our understanding of how our eyes work, the whole idea of 3 types of color receptors in our retinas, that's also thanks to Thomas Young.
Precisely. Another example of his work crossing disciplinary boundaries, lasting impact on fields far beyond physics.
I'm starting to think this guy might have had a time machine. It's just too much brilliance for one lifetime. Speaking of brilliance, how did Young's contemporaries react to all this? Did they immediately recognize him as a genius?
Not exactly. Remember, some scientists really opposed his wave theory of light. His ideas were often met with skepticism, even ridicule. It took time for his work to be fully appreciated.
So he was kind of a scientific rebel, challenging the norms, pushing the boundaries of knowledge. Kind of inspiring, actually.
Absolutely. Schneppet really highlights that. Young wasn't afraid to go against the grain, challenge the status quo, pursue his scientific curiosity.
It's a reminder that sometimes the most groundbreaking discoveries come from those who dare to question the accepted wisdom. Makes you wonder what other Youngs are out there today, pushing the boundaries of science, waiting to be recognized.
That's a great point. And it leads to the bigger question. What can we learn from Young's life and work? What does his story tell us about scientific progress, the role of the individual in shaping our understanding of the universe? I think that's something worth pondering. As we move into the final part of our deep dive...
You're right, we've covered a lot of ground. from the subatomic world to ancient civilizations. And it's all connected to this one extraordinary person. But what does it all mean? Stay tuned. We're going to try to answer that very question in part 3. All right, so we've gone through this mind-bending world of quantum mechanics. We've explored ancient Egypt, even delved into the mysteries of human vision. All thanks to Thomas Young. But now the big question. What does it all mean?
Well, if we step back and look at Young's legacy, through the lens of Schneppat's essay, of course, I think one key takeaway is the power of interdisciplinary thinking.
Yeah, he wasn't confined to just one field. Physicist, physician, engineer, linguist. It's like he had multiple brains working at the same time. And it wasn't just that he was good at all these things. He actually used his knowledge in one field to inform his work in another.
Exactly. Think about his work on the Rosetta Stone, his understanding of languages. Combined with his scientific approach to problem solving, that was essential for deciphering those ancient hieroglyphics.
So it's not about being a jack of all trades. It's about recognizing how knowledge is interconnected and using that to your advantage. I guess that's the mark of a true polymath. But is that even possible today? With science becoming so specialized, can one person really make meaningful contributions in multiple fields?
It's definitely more challenging. The amount of knowledge in any given field is just huge these days. But I think Young's story offers a valuable lesson. It's not just about mastering one discipline. It's about being open to new ideas, seeing those connections, stepping outside your comfort zone.
So even if we can't all be Thomas Young, we can try to be more interdisciplinary in our thinking, be curious about fields outside our own expertise, look for those unexpected connections that might lead to new insights.
Precisely. And that's a powerful message for everyone. Regardless of your background or profession, Young's legacy reminds us that knowledge is interconnected. Embracing different perspectives can lead to amazing discoveries.
It's also a reminder that scientific progress isn't always straightforward. Young's ideas faced resistance, ridicule even, but he stuck with it. And his work completely changed our understanding of the universe.
Absolutely. Scientific breakthroughs often challenge the accepted way of thinking. It takes courage to stand up for your ideas, especially when they go against the grain.
So next time I'm feeling stuck, I'm going to think of Thomas Young, the guy who bridged the gap between classical and modern science, unlocked the secrets of ancient civilizations, helped us understand how we see the world. He's truly inspiring.
Couldn't agree more. And as we explore the quantum realm and push the boundaries of science and technology, it's important to remember those who came before us, those who paved the way with their curiosity, their courage, and their pursuit of knowledge.
Well said. And a big thank you to Yurgo Schneppat for taking us on this fascinating deep dive into the life and work of Thomas Young. It's been a real eye-opener. And to our listeners, we'd love to hear from you. What part of Young's legacy resonated with you the most? Let us know.